A very good morning, respected judges, fellow researchers, and esteemed guests. My name is Lokintini Dutta Osamrilu. I'm honored to represent my Faculty of Civil Engineering and Technology, University Varsha Parlis, in presenting our innovative project title, which is CDW, a new sustainable constructions product. The theme involves chemicals, advanced material, and plastics. As we all know, the construction industry is our major contributor to environmental pollution, particularly through constructions and demolition waste, which cause CDW. Our researchers focus on transforming CDW into a new and sustainable constructions material, promoting circular economy principle while reducing environmental impact. Let's see the introductions. Okay. Construction demolition waste, which called CDW, aggregates are recycled material from demolished building, offering a sustainable alternative to virgin aggregates. Using CDW can reduce the greenhouse gas emission, which are carbon emission to the global through the process of laboratory and construction cost too, making it an advanced material in the industry. Thus, this innovation is first to identify the physical properties of recycled cost aggregate RCA, second, evaluate mechanical strength on compression and flexural test of specimen at a different curing period for the 7 days and 28 days. Third, assess carbon footprint CF reduction in concrete productions. Next, problem statement. There have three problem statements. The first, CDW is currently produced by the construction sector is alarming in its quantities. It depletes the environmental and natural resources needed to make a concrete. Due to this problem, the industry has made it a goal to find more environmentally friendly ways to make a concrete. Second, CDW recycling is a possible substitute for the natural resources used in the productions of aggregate throughout the last few decades. This technique has a financial benefits, such as when comparing the cost of recycled aggregates to unrecycled aggregates, these replacements contribute to saving up of approximately 4 to 9 USD and 9 to 26 percentage per meter squares of aggregates and per meter cube of concrete, respectively. As we all know, Malaysia industry using the grade 25 cubic, the sizing are 100 mm times 100 mm times 100 mm, and RM 10 ringgit are contributed per cube. Third, restrictions. Behavior of concrete low strength due to diversity and variability of the recycled aggregates feature. Therefore, it is crucial to evaluate this advanced material suitability for application from an environmental standpoint, such as reductions of carbon footprint. Next, first, preparation of specimen. RCA. Crushed CDW were collected from a destroyed building in Kanga and carried out to the lab FTKA. Second, physical property RCA, recycle cost aggregate, and NCA, natural cost aggregate. And it also has its own standard method for the overall testing. The first, particular size analysis, sleep analysis for the fine and cost aggregates. Second, density and water absorptions, specific gravity and absorptions of water. Third, ultrasonic pulse velocity, which is called UPV test. And fourth, aggregates impact value, AIV test. Next, mechanical strength. It has two testing, compression and flexural test. Before we conduct the testing, first we need to calculate the concrete mix designs. Second, we used a grade 25, which Using the cement 3 kg, water 2 kg, fine aggregate 6.41 kg, coarse aggregate 6.16 kg, and the third tested RCA concrete, they have 4 replacement we are used. First 45%, second 50%, third 75%, fourth for 80%, and lastly we compare with the natural coarse aggregate, which is can call as control sample without any replacement of RCA, and they have tested for compression and flexural test for after curing 7 days and 28 days. Next, okay. The fourth CF assessment, which is carbon footprint formula, which is EF hand equals to WC times EFBC plus WCA times EFBCA plus WFA times EFBFA. This is to calculate the carbon emission overall the laboratory. Quantity of materials and materials emission factor, which is CO2. And the cement we use total 0.74, fine aggregate 0.0052, natural coarse aggregate 0.0054, and recycled coarse aggregate RCA is 0. Next, product description. This is the diagram. With this innovation applied, the LCA system boundary of ISO 14064-1 is international standard greenhouse gas is inventory in organization level for the measuring. Okay, this has a diagram show the input, the material we are used, and then the process, overall the process, and then from here we can see the carbon emissions and then output. Next, the physical properties. First, specific gravity, 2.38 RCA and 2.56 NCA. Fourth, water absorption, 7.77% of RCA and 3.43 NCA. And this is the table of aggregate impact value. And this is the graph. RCA is more greater than NCA. Next, this is the table that we can see the ultrasonic pulse velocity for the replacement percentage for 45% and 80% with the compared with the natural coarse aggregate control sample. Okay. From here we can see the curing period for the 7 days and 28 days and ultrasonic pulse value. Size range we are used 12.6 to 20 mm, which is 60.52%. UPV value is range 2.97 to 3.65 km per second. It means average qualities and reflects some journals, and it is which is for the 28 days curing period. Replacement we just take the 45% and 80%. From here we can see the strength of itself, and fourth is AI value is 80%, is normally can see big for truth sufficiency, and this is sleeve sizes, and we also take the weight of RCA particles of each sleeve sizes and percentage passing. After that, the mechanical properties. Highest compressive strength recorded for 45% and 50% substitution of 24.6 and 24.58 MPa for the curing 28 days. And this is the highest value for the two replacements. And then specimen give less of carbon footprint at the range of 0.2498 and to 0.2500 kg CO2 equations, and is accumulate 1.03 to 1.11%. So it's approximately for 1 cube, and then the sizing for the 3 kg specimen as compared to control specimen. This will be less to cost effective. And then RCA 45% replacement gave the highest flexural strength of 3.12 MPa at curing period of 28 days. And this is the flexural strength graph. This is for 7 days and this is for 28 days. From here we can see the 45% and the 50%. So this is the control sample. So control sample is basically give the highest strength compared with the replacements. And in comparison in control, 3.77 MPa. So CDW aggregates in advanced concrete reduce bending resistance while providing environmental benefits over virgin material, so that the carbon emission decreases as the replacement getting higher, but the strength may reduce. Okay. Next. Okay. Novelty and energy phase. So this innovation concrete product represent a significant advance in the construction industry by integrating recycled CDW, offering both high strength and lower CF carbon footprint. Comprehensive strength of 24.6 MPa surpasses the standard requirement for grade 25 concrete, ensuring its suitability for structural application. Additional, the carbon emission from its productions are reduced by 1 to 2% per kg of concrete. Per 3 kg of concrete contributed to sustainable construction practice. So it also ability to transform CDW into high performance materials aligned with the global sustainability goals and merging CIDB efforts to minimize waste. And it also conventional concrete product not only retain superior mechanical properties but also reduce dependency on virgin raw material, this promoting circular economy in the construction sector. Okay, next slide is potential use and STO. Potential application. Okay, first structural element. It can be used on beam, slab, and column in the low to mid-rise building. It can be used for high-rise building. Second, precast concrete product. It can be used for blocks, pavers, and wall panels. And third, infrastructure projects. So it can be used sidewalks, road barriers, and retaining walls. For the green building initiatives, so this is our leadership in energy and environmental design LEED certification sustainability program. And this innovation mapped to SDG to number 9, which is industry innovations and infrastructure, and number 13, which is climate changes. And thank you from me.